Welcome to this comprehensive guide for C# beginners. We'll explore fundamental data structures, key-value pairs, hash sets, and dictionary iteration. Mastering these concepts is crucial for efficient C# programming and building robust applications. Understanding how to efficiently store and retrieve data is crucial for any C# developer. This knowledge lays the groundwork for building complex, scalable, and high-performance applications, enabling you to tackle advanced programming challenges. Let's begin by demystifying key-value pairs. This foundational element is a core building block within many C# data structures, providing a simple yet powerful mechanism for associating two pieces of information. Grasping this concept is vital for beginners. A key-value pair is simply two linked data items, a unique key that identifies a piece of data and the value itself. For example, a student ID could be the key, and their name the corresponding value, creating a direct association. Think of it like a dictionary. Each unique word acts as the key, while its definition is the value. This structure makes information retrieval incredibly intuitive and fast, as you directly access the definition by knowing the word. This pairing allows for exceptionally fast and direct retrieval of values, provided you know the associated unique key. Instead of searching, you can pinpoint the exact data almost instantaneously. This direct access significantly boosts performance. Now, let's move on to hash sets, a powerful collection type in C#. It's designed for efficient storage and management of unique elements, ensuring every item within the collection is distinct and preventing any duplication. A hash set ensures every item it contains is distinct. If you attempt to add an element already present, the hash set automatically ignores the duplicate, maintaining the integrity of its unique collection without throwing an error. Creating a hash set in C# is straightforward. You declare hash set T, where T is the element type. For example, hash set string unique names equals new hash set string creates a set for unique strings. Adding elements to a hash set uses its add method. This operation succeeds and returns true only if the element is not already present. If it's a duplicate, add returns false, and the set remains unchanged. Checking if an element exists within a hash set is incredibly efficient thanks to its underlying hash-based implementation. This rapid lookup capability means that regardless of the set size, checking for an item's presence remains remarkably fast. To perform this efficient check, use the contains method. It returns true if the element is found, or false otherwise. This is perfect for quick membership tests, such as if to verify existence. Hash sets are ideal when you need to manage unique items and perform quick lookups. Common applications include tracking unique user IDs, filtering duplicate entries from a list, or efficiently checking if an item has been processed. Next, we delve into dictionaries. These are powerful collections designed to store and manage key-value pairs. They provide a structured way to associate a unique key with a specific value, offering efficient data retrieval based on these keys. Just like a physical dictionary, C# dictionaries efficiently store and retrieve values using a unique key. Each key acts as a direct address to its corresponding value, enabling rapid access to specific data points without sequential searching. When creating a dictionary, specify the exact data type for both its keys and values using generic type parameters, like dictionary, tkey, tvalue. This explicit typing ensures strong type safety and allows the compiler to catch potential errors early. Adding new key-value pairs to a dictionary uses the add method, requiring both a unique key and its value. Dictionaries enforce key uniqueness. Each key must be distinct within the collection to maintain data integrity. If you attempt to add a key-value pair where the key already exists, a runtime error, specifically an argument exception, will occur. This highlights the importance of ensuring key uniqueness or handling potential duplicates gracefully. Accessing values directly by their associated key is one of the most powerful features of a dictionary. This direct access allows you to retrieve specific data points almost instantly, without iterating through the entire collection. The most common way to access a value using its key is square bracket notation, similar to an array index. For example, user profiles, user ID, retrieves the profile. This syntax provides direct and concise access to the associated value. This direct key-based access provides extremely fast lookup times, often achieving near constant time performance. This efficiency makes dictionaries ideal for scenarios demanding quick data retrieval, such as caching data or mapping configuration settings. While direct access by key is powerful, you often need to process all or a subset of dictionary data. Understanding the various ways to iterate through a dictionary is crucial for effectively processing its content systematically. The most common method for iterating through a dictionary is using a for each loop with key-value pair, tkey, tvalue. This treats each entry as a single unit containing both its unique key and its associated value, making it convenient for comprehensive processing. When using the key-value pair approach, each iteration provides an object encapsulating both the key and its value. You can directly access item, key for the identifier, and item, value for the data, allowing simultaneous processing of both components. For example, if you have a dictionary storing product IDs as keys and prices as values, you could iterate to display each product's identifier alongside its price, like product ID 101, price $19.99. Another useful method is to iterate solely through the keys of the dictionary. This is efficient when your task only requires identifiers, and you don't immediately need to access or process the associated values. To achieve this, iterate over the keys property of your dictionary. This returns a collection of all unique keys. For instance, a for each loop processes each key individually, without value overhead. This method is useful when operations are exclusively based on identifiers and values are irrelevant. For example, checking if specific keys exist or generating a list of all available identifiers optimizes performance by avoiding unnecessary value processing. Conversely, sometimes you need to process only the values stored within the dictionary without concern for their keys. C# provides a convenient way to iterate through just the values, allowing you to focus purely on the data points themselves. To iterate through only the values, access the values property of your dictionary. This returns a collection of all values. A for each loop processes each value individually, decoupled from its key. This method is perfect when processing all data points collectively, without needing specific identifiers. For instance, calculating the total sum of product prices is most efficient by iterating over the values collection, ignoring individual product IDs. The choice of iteration method depends heavily on your specific task and what information you need to access. Thoughtfully selecting the most appropriate method can significantly impact your code's readability, efficiency, and overall performance. For instance, if updating records, iterating through key-value pair is often most direct. You need the key to identify the record and access its current value for modification, making both components essential for the update operation. If checking for the presence of categories or identifiers, iterating exclusively over the keys collection is more efficient. This avoids the overhead of retrieving and processing associated values when they are not relevant to your current check. Furthermore, if performing aggregate calculations or transformations on all data points, such as summing numerical values, iterating directly over the values collection is often the most ideal and streamlined method, focusing purely on the data. It's vital to remember that dictionaries are highly optimized for extremely quick lookups by key. This inherent efficiency makes them an indispensable cornerstone of efficient C# programming, especially when dealing with large datasets. Here's a crucial tip. Always proactively consider the potential for a key not existing within the dictionary when attempting to access a value. Failing to do so can lead to runtime errors, specifically a key not found exception. To mitigate key not found exception, try-get-value is a safer alternative to direct access. It attempts to retrieve the value and prevents errors by not throwing an exception if the key isn't found, making your code more resilient. The try-get-value method takes the key and an out parameter. If successful, it populates the parameter and returns true. If the key is not found, it returns false, allowing for clean conditional logic without exceptions. Another best practice for safe dictionary access is to use contains key before direct access. This method checks if a key exists and returns a Boolean. If contains key returns true, you can then safely proceed to retrieve the value. Implementing these checks, like try get value or contains key, is paramount. It prevents unexpected runtime exceptions by gracefully handling scenarios where a key might not exist, making your code significantly more robust and reliable. In summary, key-value pairs are fundamental building blocks for logically associating two pieces of data, where one uniquely identifies the other. They form the conceptual basis for more complex data structures and are essential for organizing information. Hash sets excel at storing unique collections, automatically preventing duplicates. Their hash-based implementation allows incredibly rapid existence checks, making them ideal for quickly determining if an item is already part of a set, ensuring data integrity. Dictionaries provide powerful key-based data storage and retrieval. Building on key-value pairs, they offer direct access via unique keys. Flexible iteration options allow processing full pairs, just keys, or just values, adapting to various programming needs. Mastering these fundamental data structures, key-value pairs, hash sets, and dictionaries, is a significant step toward becoming a proficient C# developer. This knowledge empowers you to design and implement more efficient and scalable solutions for complex problems. To solidify your understanding, continue practicing with real-world examples. Experiment with different scenarios, build small applications utilizing these data structures, and observe their behavior. Hands-on experience is invaluable for deep learning and integrating these concepts. Thank you for joining this comprehensive tutorial on C# data structures. We hope the detailed explanations and practical insights have illuminated these essential concepts, equipping you with the knowledge to confidently apply them in your C# programming endeavors. Our primary goal was to provide you, the C# beginner, with a clear, actionable, and practical understanding of these essential data structure concepts. We trust you now feel more confident in effectively using key-value pairs, hash sets, and dictionaries. As you move forward, keep coding consistently, applying what you've learned, and exploring the vast possibilities C# programming offers. Continuous learning is key to unlocking your full potential as a C# developer. Happy coding!